In this problem, we would like to get the average of the numbers. And for a while, that was the average of the numbers. And for a while, you might think that, okay, it's very similar to the summation. But we have one problem, which is dividing by the total length of a list. Now, you need to think in a recursive way. You shouldn't try to think, okay, let's compute the sum and divide here by the average, because now the function itself, it doesn't do the task. We need the function itself to be ready to compute the sum and divide by the average itself. So now, how to think in a recursive way? Let's say you have this list of 4 numbers, 1, 2, 3, 4. And let's say we solve the subproblem 2, 3, 4, which will be 2 plus 3 is 5, 4 is 9, over 3 is 3. If you have the average of these 3 numbers and you would like to extend it to a new number, all what you need is to return back this average to a summation. So now the average is 3 and there are 3 numbers, so the actual sum is now 9. Now you can add 1 to the 9 is 10 and divide by the new average. This idea here should lead us to this simple idea. You have the list, you handle the base cases, empty list or list of one item, and then let's compute the average of the remaining numbers. If n was 4, then we are now computing the average of 3 numbers. Once we are done here, we will multiply back this average by the number that it was used to divide them. So in a list of 4, this is a list of 3. So these numbers are some numbers that are summed then divided by 3. So when we multiply back with 3 again, we get back the sum of these numbers. And then we divide by the new average. So this is how we made use of the sum. How can we convert the average to sum so that we can make use of it? In the next problem, we would like to do a list incrementing with the length in a decreasing way. If length is n, so we add like 5, 4, 3, 2, 1, and so on. The idea is going to be very simple here. We would like to construct a new list. So if the list has some list here of length n, then we can just add it to the current element. This is going to be the first element in our list. And then we recursively do an incrementing to the remaining of the list. The returning from here is a list, and we can take our first element and add it to a new list and then just return it. For example, let's say we have the value 1 in this list of 5 elements. So 5 will be added to the 1 is 6. So current is now 6. And this will be a list of 6 elements. And this function is going to take all of this number and do a list incrementing. Remember our rules, focus on the what more than on the how. What will this function do? This function will take 8, 2, 10, 3 and return it back to 4 plus 8, which is 12. So it's going to return here 12 and 5, 12 and 4. So if we have this returned sublist, we add to it its current list, and that's all. You see how I don't have to keep tracing and tracing and tracing the numbers? So consider that. Finally, here in the accumulation one, this is a bit tricky, might be, but I already said the observation during my session, during the listing the homework, something like 21. 21 is the previous accumulation plus the current element. 15 is the previous accumulation plus the current element. When you study dynamic programming later in algorithms, you will know that this is one of the trivial examples of dynamic programming where like things are that very linear. So let's go back to our code here. I would like to make use of this observation. So first of all, I take the remaining of the items here and compute the accumulation of it. Okay, this is exactly numbers from the begin to like the one before it. For example, for items 1, 8, 2, 10, 3, this list of up to -1 is going to be 1, 8, 2, 10 only. So now we are going to accumulate this 1, 8, 2, 10 list. After that, what we need to do, we need to get the last accumulated number and add it to the current last number. Once we are done with that, we append it to the head and return it. Again, think in a recursive way. Here in the sequence, let's say we are at 21. We would like first to get this accumulation. That's why I was thinking, let's cut the numbers 1, 8, 2, 10 and get their accumulation list. So by recursion, the list here is going to get for me the accumulation of these numbers, which will be at let's say 21, and then I'm going to add my number, which is now the 3, to the numbers. I hope you can now understand what was happening here. And again, even if you cannot get the recursive idea by yourself, I would like you to be very clever in tracing recursion to get it very fast. What will this function do? It will take the first 4 elements, compute their accumulation. How? I don't care now. What is the accumulation? It is 1, 9, 11, 21. What I'm doing here, I am taking the 21 and adding it to what? To 3, and appending it, so it's now 24. This way, in a couple of minutes, you traced a recursion function that you even couldn't write by yourself. That's all.